Hello, good morning, everyone, and my presentation is going to be about machine learning. My name is David Huerta, and let's begin. Okay, so what is machine learning? Machine learning is an artificial intelligence, otherwise known as an AI application, which provides systems with the ability to learn and improve automatically from experience without being programmed. The focus of the machine learning is on creating computer programs that can access data and use it to learn from themselves without the need of human intervention. The learning process begins with an observation or information, such as examples, direct experience, or feedback to search for trends in the data and make informed decisions in the future based on the examples we receive. The primary objective is to allow computers to automatically learn without human involvement for assistance and to modify behavior accordingly. So, wait, what? I said the same thing too as when I was learning about machine learning. My initial thoughts and questions were like, usually when you program a computer, you tell that 1 plus 1 equals 2. It does not learn from that, and you tell it what to do. And my thoughts were like, well, how can a machine learn? Like, you input what it does, and that's it. It does that. So, I think the best way to understand machine learning is by doing an example, a basic, simple example to be exact. So, all right, let's see the drawing on the right. Let's represent that as Jimmy. And Jimmy enjoys certain types of toys, but not others. So, in our fake example, here he decides his base on how big the toy is and how complicated it is. So, from small to big, and then over here is the toy size, and over here is the toy complexity. So how many parts it has, from just one piece to really a complex tier with gears and moving parts and things like that. So if we ask Johnny about 20 different toys and start to plot those on the graph, we begin to see a pattern. So let's say red is dislikes, green is dislikes, and we plot each and every single point on the graph. Okay, so generally, he likes toys that are big and complicated, but does not like toys that are small and simple. So by looking at this, at his past preference, we can make a really good prediction for the future if you show Johnny here a toy that it is really complicated and big at the same time. And we're so confident that he'll like it because it is inside our like boundary. So this circle over here is going to represent our like boundaries, and this circle over here is going to represent our dislike boundaries. So we don't have to take the time and show Jimmy every single toy that has been created to record his answers. After we record some likes and dislikes, we're able to draw some boundaries, and precisely where we draw those boundaries is the secret. In this case, with just 2 inputs, you can just eyeball it and see where to put the boundaries. But if you have 1,000 of inputs that interact with each other, it's really impossible for our brains to comprehend where those boundaries should go. However, it's pretty trivial for a computer using machine learning. Okay, so how does a machine solve this? The short and fast answer is a neural network. So what is a neural network, you may ask? So a neural network are a series of algorithms that are loosely modeled after the human brain and intended to identify patterns. They view sensory data by means of a form of raw input machine perceptions and naming clusters. So I'm gonna try to explain this and give an example. So on our left side, we're gonna have input A, B, C, D. On the little middle side, let's call that our hidden nodes or hidden inputs, and those interact with each of the inputs that we have set. So A, B, C, D, and by that interacting, it all interconnects to either 2 outputs, a 0 or a 1, a yes or a no. Okay, so let's do a quick example. So input A, input B, input C, and input D are how I'm feeling in the morning. So let's say I am tired, let's say I'm happy, let's say I am angry, and let's say that I am groggy. Okay, so, and with those set of data, I am able to decide whether what I want for breakfast. So when I'm either happy, I would want eggs for breakfast. If I'm either angry, I would want a milkshake for breakfast. So with those inputs, the machine are interacting with each of the hidden inputs and deciding, oh, when he's happy, he wants eggs for breakfast. So it either decide, is it eggs or is it a milkshake for breakfast? So by giving a set of data, the machine is able to decide and predict what do you want for your breakfast by deciding the mood or the basic data that you're provided already. So let's say, for example, you get a 0.5, something that's either 0 or 1. Well, you can't really have half of an answer, really. So that's why you give it data points to begin with, so it can decide, oh, that half of a 1 is actually a 0. He doesn't want anything for breakfast. Or, oh, that 0.6 is actually a 1, and he actually does want a milkshake for breakfast. So by giving it, say, data points, the machine is able to correct like half answers into full answers. And by doing that, it's able to predict better and better and better after each time. Okay, so this is usually how a neural network looks like. So there's a bunch of dots, and these dots are all working interconnecting, and they're all adjusting with each other, and they're all how do I say this, like connecting in a sense. Yeah. So after a certain point of adjusting the hidden layer too often, it will cause your output layer to be less accurate, in which case you should stop and set the hidden layer and not adjust it anymore. And after adjusting the nodes, you're down to 2 outputs, 0 and a 1. So this is how a computer, or like how we present a neural network, and this is how a neural network in our brain also looks like. So they're both very similar. It is based off of our brain, and that's also how we learn as well. And I'm gonna get into that in the next slide. So this is how we learn too. So this is basically how our neural networks in our own brain setups for us to learn. If you've been given enough time and training data to understand the interaction between balancing an item on your hand, then you don't need to train for every single possible item that requires balancing, but instead only the training data. So when we try to balance a completely new item, we're not required to learn from it since we already had training data. So let's say I decide to learn how to balance a stick with my hand. I have training data, and now I know how to balance an item on that hand. So when I try a new item that I've never balanced, I would be able to balance with that item because of the training data that I had. So this guy over here is balancing a flamethrower, and he's able to balance that due to his training data. Okay, so applications of machine learning. So image and speech recognition, medical diagnosis, learning association, product recommendation, classification, prediction, extraction, traffic prediction, and language translation. So the applications of machine learning are very far and wide. I only put 10 down here, but there's way more than just 10. You can literally create your own like application if you want to, or have, create your own code and decide whether what you want, what you don't want, and what you want predictions for the future. So all you need to do is give it a data set, and the machine will learn how to predict with that. So conclusion, with the increased demand of AI and machine learning, organization requires professional with ins and out knowledge of these growing technology and practical experiences. And here are my sources, and that is my presentation. Thank you.